In this video, I want to give you a very brief overview of how to use the graphing calculator to graph. And although you see a TI-83 here on the screen, please know that the same calculator keystrokes that we talk about in this video can also be used on a TI-84. So to start, we will use this example, y equals 2x plus 1, and we will begin by typing this into our graphing calculator. So locate the y equals button here on the upper left hand side of the keyboard. When you click y equals, you should see a screen that looks like this. And this is essentially giving you the y equals part of the equation, and your job is to type in the rest of it. So we need to type in 2x plus 1. To do that, locating the 2 is hopefully very easy for you. So the 2 is here. Now the x key to get the x is located right here, just under the mode key. So when I click that, you'll notice that it gives me an x up here on the screen. The plus key is down here in the lower right hand corner, and then we'll type the 1. So here on the calculator screen we have y equals 2x plus 1. You don't need to worry about any of these other y equals. This is just what allows you to type multiple equations, which we will get to at some point, but right now this is just the basics. So we've got y equals 2x plus 1, and to see a graph of that equation, we locate the graph key here, and when we click the graph key, our calculator shows us a graph of this equation. So pretty cool stuff. And just so you know, a couple other little things real briefly here. The window key is going to allow us to change our window. In other words, right now what we are looking at is an XY axis where we are going 10 units in the positive x direction, 10 units in the negative x direction, 10 units in the positive y direction, and 10 units in the negative y direction. If we want to alter that, we click the window key, and notice it's telling us that the minimum x value is negative 10, the maximum x value is positive 10, the tick marks are jumping by 1, the minimum as far as the y-axis is negative 10. The maximum for the y-axis is 10. And again, the tick marks are jumping every 1 unit. And as far as this x-res, you can disregard that for now. So if we want to change the look of our window, like let's say that instead of like a 10 by 10, we want to see it as a 5 by 5, we can do that very simply by simply typing -5 for the x min, 5 for the x max. I still want my tick marks to jump in increments of 1, so I'm going to leave the x scale the same. The y min I would like to be -5. The y max I would like to be 5. And again, I would like the tick marks on the y-axis to jump in units of 1 as well, so I'll leave that the same. And now when we click the graph key, notice that in a way it kind of zooms in on the graph, and instead of each of the axes going 10 units in each direction, now they're going 5 units in each direction. And by making our window a little bit smaller, we kind of can see a little bit better what's going on here on the graph. You can see a little bit better, for example, that the y-intercept is at 1. And so that's just a very brief kind of explanation of how we utilize that window key. Okay, something else that's really cool when you graph a function is that we can access a t-table representing all of the values that this graph spans. So check this out. In order to access the table, we will click second and then the graph key. So second, graph. And what you're looking at here is essentially a big giant t-table, or what some people also refer to as an XY chart. For example, when x is equal to 0, y is equal to 1. When x is equal to 1, y is equal to 3, and so on and so forth. And you can use the down arrows to scroll through the chart in the positive x direction, or you can use the up arrow to scroll into the negative x values. So for example, when x is equal to -5, y is equal to -9. So the table feature is a really neat feature to use, especially when you would like to graph an equation using a table of values. The drawback to what you see here is that our x values are automatically defaulting to integers. So like 0, 1, 2, 3, and -1, -2, -3. And the question is, what if I want to evaluate this equation for an x value that's not a nice integer? For example, what if I wanted to know the y value when x is equal to 1/2, for example? Well, here's how we can set up our calculator in order to allow it to input any x value we want and give us that corresponding y value. I want you to hit the second key and then the window key. That's going to take us to the table setup screen. We're going to scroll down to the independent line, and you may recall that the independent variable is also known as the x variable. I'm going to use my right arrow key to highlight the word ask, and I'm going to click enter so that ask is highlighted permanently. And then I'm going to go back to my table by clicking second graph. And you should see a blank XY chart here. And what this is going to allow us to do is input any x value we want and have the calculator tell us the corresponding y value. So like we mentioned before, let's say we want to know the y value when x is equal to 1/2. I can click 1, and to denote the fraction bar in 1/2, I can use the division key, and then 2. So notice I've typed in x equals 1/2 here at the bottom of the screen. And when I click enter, the calculator tells me that when x is equal to 1/2, y is equal to 2. And you can type any kind of value in here that you want. So let's say that we wanted to know the corresponding y value when x is equal to 1,000, a really big number. And if we hadn't changed our table setup, can you imagine having to scroll through that table of values until we got to x equals 1,000? It would have taken forever. So using the table setup and making a couple changes, we can now type in x equals 1,000, and with just a click of a button, determine that the corresponding y value is 2,001. So this is a very cool feature because what it allows you to do is it allows you to type the equation that you're working with into the graphing calculator, and this feature will help you in tabulating your XY chart for graphing. So it can be a very cool thing to know how to do as you're graphing these equations. Now, as you might have already thought, one kind of limitation that the graphing calculator has when we want to graph is that when we click the y equals button to input our equation, we must have an equation that is already solved for y. So for example, let's say I give you this second example here at the bottom of the screen. 7x plus 8y equals 2. If you want to graph this equation using the graphing calculator, or if you want to create a table of values using the graphing calculator as a help, you will need to solve this equation for y first. And I already took just a minute to do that so that we would know what we're typing into our graphing calculator. I subtracted both sides. I subtracted 7x from both sides, and then I got this result here, 8y equals -7x plus 2. And then I divided both sides, or each piece, by the number in front of y, which was 8, and that simplified to y equals -7 over 8x plus 2 over 8, and then when we simplify 2 over 8, we of course get 1/4. So now once we've solved for y, we can type it into our graphing calculator, and then we can graph it or use the graphing calculator to create a t-table or whatever you need to do. And I just want to give you a note of caution when you're typing fractions in. My recommendation is to always, always, always use parentheses around fractions. So when I type this into the calculator, I can type over the equation that I previously had in there, or I can click the clear button to clear out what I had in there and start fresh. And I will put the -7/8 in a set of parentheses as follows. Notice that I used the negative key down here to the left of the enter key to type that negative sign. And then I am going to click the X, and then I'm going to click the plus sign, and then I'm going to put the 1/4 in a set of parentheses all on its own. The reason that we put fractions in, the reason that we put parentheses around our fractions is to make absolutely sure that the calculator understands what we're working with. So, for example, -7/8x. If we had left the parentheses out of this, the calculator might not have understood that the coefficient of x is -7/8. It may have thought that the coefficient was just the 8, and it could have provided incorrect results when we graphed it or when we found our table of values. So as a general rule of thumb, again, I cannot emphasize it enough, anytime you type a fraction, whether it be for calculating, for graphing, or whatnot, always put parentheses around it. Okay, now that we've done that, we can go ahead and graph this guy. So we'll hit the graph key, and notice that our window, as we last had inputted it when we changed the mins and maxes to -5 and 5 respectively, those settings still hold. If we want to go back to the original setting of a -10 to 10 window, one quick and easy way to do that is to click the zoom key, and the standard window is the default window. So we could scroll down to number 6, click enter, and it would default back to the 10 by 10 kind of window setup. But as you can see, when we pull back and kind of zoom out, it's a little bit difficult to see, for example, where the graph crosses the y-axis. And so zooming in and using a smaller window may be a little bit more advantageous in this case. But at least you can kind of see how to change the window and also how to get back to that standard window using the zoom key and then option 6. And then we can utilize our table to create a table of values, again by clicking the second key and then the graph key, and we can input any x values that we want in order to determine the corresponding y values. And if you want to go back to the standard XY chart that we had to begin with, I'll just kind of go through that to end this video. You would hit the second window key and then use your down arrow to go to the independent line, and the auto is highlighted. That's what we want to go back to. So we will click enter to highlight auto and then go back to our table of values by clicking second graph. And there we are back to our standard t-table where it already gives us the integer values for x as well as the corresponding outputs, and we can scroll through there as we need to. Now, the advantage of doing this when your equation contains fractions like this one does is because when we put in an x value, our output is very likely going to equal a decimal or a fraction value. Using the standard default XY chart in this way allows us to scroll through the values to see what x values will give us quote unquote nice corresponding y values. So in other words, when x is equal to 6, y is equal to a nice neat -5, which we can graph very easily. when x is equal to 5, y is not equal to a very nice number that we can graph very easily. So we can use this XY chart to scroll and find the x values that give us nice, neat output or y values. So the next one would be x equals -2, gives us a nice, neat, graphable y value of 2, and you can continue to scroll through this chart to find as many ordered pairs like that as you need for graphing. So another example would be x equals -10, gives us a nice, neat y value of 9.